Hi, I wanted to record a little something for y'all to help you out with your project so you could test it out in the lab. So, if you have not already watched the videos from the sessions where we talked about the project, I recommend that you go back and do that first because I'm assuming that you already know what we talked about in the previous sessions. We went over, we talked about in detail what the module should do, and we came up with the different states. In particular, if you go back and you look at those sessions, you'll see how we came up with a partial state diagram that looks something like this, and what it meant. And if you just look at this, it's not going to make any sense. So you'll have to go back and watch the video for that. Okay, so another thing we talked about was the constraints, but I will walk you through that because that's pretty straightforward. So you need to have the right kind of clock, and so to get the clock, you go to this PDF in the Moodle, and at the very end it has to use a button as a clock signal, so that's what you'll need for your clock. So constraints, I'll need a new constraint file. Take out those line numbers that were there. I'm noticing here that it's called clock or CLK, so I want to make sure that's the name that I use in my program. And I usually use the little extra button module that I've demonstrated, and that's pin J11. But you will want to use whatever you're supposed to use. I think the project description says to use D something or another. I would still use the button module because I don't like the buttons everywhere else. Okay, alright, so now we need to have, the project is supposed to have 4 switches and 4 LEDs, and it specifies which ones to use. And I would get those from the constraints that I posted in the SI resources. And I believe it was switches 1 through 4. And LEDs 7 through 10, I think. Okay, and then I believe these were to indicate floor 1, floor 2, floor 3, and door open, and that these lights indicate, so this is the switches you're calling floor 1, floor 2, floor 3, and the door is blocked. And these lights are indicating that you're on floor 1, floor 2, floor 3, or that the door is open. Okay, then your actual code. So we will have as our output LED, our input is switch and CLK. Input CLK. Input what was it? 41 SW. Output reg 10:7 LED. Okay, so what this is telling us is that our variable switch has positions, and we have switch 1, switch 2, switch 3, and switch 4. And so when this is 1, it means floor 1 has been called. And if this is 0, it means floor 2 is not called. And if this is 0, floor 3 is not called. And if this is 1, it means the door is blocked. And so when I'm looking at the switches, if I have that my switch equals 4B 1001, that corresponds to what we have here. If I have my switch equals 4B 0011, this is position 4, 3, 2, 1. So this means that floor 1 is called and floor 2 is called. If I have switch equals 4B 1000, this means that the door is blocked. And none of the floors are called. Similarly, if I look at LED, I've got LED 7, LED 8, LED 9, and LED 10. Now, only one of 7, 8, or 9 is going to be on at any given time, because this tells you what floor you're on. So if I had 0, 0, 1, 0, this would mean, oh, this is telling me if the door is open or not. So it would be door closed. So this corresponds to 0, 1, 0, 0. But that's position 10, 9, 8, 7. that means I'm on floor 3. Floor 3. And the door is closed. So if I had 1, 0, 0, 1, I would be on floor 1 with the door open. So the value of LED is 4 bits, and the most significant bit will tell you if the door is open or closed, and the next 3 will tell you what floor you're on. Okay, then in your program, and you do not have to do this way. This is just this is a combination of my suggestions as well as what the group came up with when I met with them for the state diagram. But you can do it in other ways. You also are, but no matter what, you're going to need reg. And depending on how many states you have will depend on how big it is. We had 9 states, and with 9 states we need to have at least 4 bits. So we're going to have reg 3:0 current state and next state. Then you don't have to, I recommend that you give names to all your states. So parameter, and I'm just going to call them floor 1A equals 4B0000. Floor 1B equals 4B0001. Floor 1C equals 4B0010. And the way we came up with it, and I haven't actually written the program already out, all the way out, so I'm not for sure that it works, but it made sense to me. We only had 9 states. Last year we had more states than that, but we had a different kind of project. So we'll have floor 2A, and that would be 1, 2B, 100, 2C, 101, and 3A, 0110, 3B, 0111, and 3C, 1000. Okay, so those are just naming our states. And if you haven't watched the video or haven't thought about what your states are going to be, it's not going to make any sense to you. But you need to think about what states you're going to have. I think I will also, I haven't done this in previous years, but I think this will make it clearer to people. I'm going to make some other parameters. I'm going to say parameter. This will be the signal, so I'll call it floor 1 open. Maybe I'll just call it open 1 equals, and what would the LEDs be for the open door on floor 1? It would be 4B0001. Do I want to uppercase these, lowercase them? Closed 1 equals 4B1001. So these are the signals for the LEDs. Just so that I don't have to actually specify them by number each time. And 2 would be 1 0 1 0. And 3 and those are what we will use for the outputs. Where did I put it to? Okay. All right, so then you're going to have 3 always blocks. And your first always block is going to be always at current state. Case current state. So this one is going to be to set your outputs. And so you're going to list all of your states. So for 1A, for 1B, for 1C, for 2A, for 2B, for 2C, for 3A, for 3B, for 3C. And then because we did not use up all 16 possibilities, you do need to make sure you include a default. And LED equals, so if I'm on floor 1A, I want that to be closed 1. If I'm on floor 1B, actually it doesn't matter. Yeah, I can just use equals here. Doesn't matter. Open 1. Open 1. Close 2. So I'm just setting, and this may not be the way yours is set up. This may not be the way you want yours to be. And I'm just kind of picking these, saying this is what I would have on for my outputs for these different states. So this is a more machine. So if I am on in this state, then I would have my outputs would be equivalent to closed 3, and closed 3 gave me this output 1100. So the LED 10 is lit and LED 9 is lit, and 7 and 8 are not lit. And if for the default I will have none of them lit. Also, I need to have an end case. I am going to have up here current state, I'm going to have it initialized to be floor 1A. So what this says is anytime I change states, I'm going to change my output based on what state I'm on. Okay, so that's your first always block. Your last always block is going to be always at positive edge clock. And you have your current state is equal to your next state. So that's your last always block. And the always block that's in between is going to be the one where you do your combinational logic, where you determine what your next state is actually going to be. So this is going to be where all the hard work is. So this is going to be always at current state and switch. And the way this one's going to work is you're going to have a case based on your current state. So we're going to have, like we had up here, we're going to have a case for each state, but it's going to be a bit more complicated than this. For this, it was a Moore machine, so the output didn't depend on the current input, but the next state always depends on the current input. So we'll have this, but each one of these is going to have several things involved with it. This is the hard work. Let's see, so by default, so this is not going to be, you're not saying what the LED is, you're going to be saying what the next state is. So my default is going to be my next state is equal to, what did I call floor 1A? I just picked one. Okay, for all the rest of these, your next state is probably, for most of them, going to depend on the switches. There may be some states where it doesn't depend on the switches. So, for instance, we had in ours, we had that if you were on floor 1B, your next state, regardless of anything that was going on, was floor 1C, if I recall. Let's see if that matches our state diagram. We said, yes, we were on floor 1 with the door open. Oh, we had our output, it was lit if the door was open and not lit if it was closed. Did I do that right? It's lit if the door is open and dark if the door is closed. But see, because I did this, I only have to change it here. I don't have to change it anywhere else. Okay. Alright, so floor 1B, we don't have to have another case statement. We can just say next state is floor 1C. And I can do something similar for these. Okay, but for the rest of these, it's going to be a lot harder. Okay, so I'm going to walk you through doing this first one based on how we discussed it in our session. So for most of these, you will have a case that's going to be based on the switches as to what the next state is going to be. Okay, so let's talk about floor 1A. That corresponds to what we said was floor 1 door closed. So we said, let me go back and look. We said that if we didn't care what the first one was. So, and the switches, so we didn't care if the door was blocked or not because the door's already closed. So that was a don't care. So we said if we had the first one was don't care, but then we had 0, 0, 0, then our next state would be floor 1 door closed. So the way we do that here is we do 4B X 0, 0, 0 colon next state is floor 1A. Okay, so now let's see, what else did we say? We said if the first three were don't cares, but floor 1 was selected, we went to floor 1B. And then we said for don't care 010 and don't care 110, we went to floor 2B. So basically if floor 2 was selected, we went to floor 2B. Notice that would be equivalent to saying this. We don't care if floor 3 is selected or not. If floor 2 is selected and floor 1 is not, our next state is floor 2B. And then we said if floor 3 is selected and floor 1 and 2 is not, then we said that we would go to floor 2A. Then you have to make sure that you've accounted for all possible states. So every X counts for 2 states. So this first one counts for 2. The second one counts for 8. 2 plus 8 is 10. This third one counts for 4. 10 plus 4 is 14. This last one counts for 2. 14 plus 2 is 16. So all 16 are accounted for. Shall we go on and do floor 1C? So floor 1C, we had, if it was all zeros, we went back to floor 1, door closed. And then if we had a 1, we stayed where we were. Yeah, the door's blocked. Yeah. Oh, we should put a default in here. You want it never to get to that. You want to make sure that you've accounted for all 16 states, but you need to put it in here. And you can make it be whatever you want it to be. But do make sure you put one in for each one of these. Okay, what else did we have? We had, if we selected 1, we went back to floor 1B. Zero DD1. And then if we selected floor 2, we went, okay, so this one was the same. I think that catches all of them. See, that accounts for 1. There's another one, so that's 2. This is 4, so 2 plus 4 is 6, plus 2 is 8, plus 1 is 9, so I'm not anywhere near done. Let's see, what have I forgotten? Did I do the 1 DDD? I did not. This was not 1 0 0 0. This is 1 X X X. So that accounts for 1 plus 8 is 9. 9 plus 4 is 13. 13 plus 2 is 15. Plus 1 is 16. Okay, so now I've accounted for all 16. Okay, so that is how floor 1 works the way we did it in our session. So you have to figure out floors 2 and 3. And if you have no clue what's going on, you need to go back and watch the videos. And if you haven't watched the videos yet, and you're thinking that, well, I'll just go ask, I'll be able to tell whether you watch the videos or not. I will. So, and if this is all you have, like if you have exactly this, and everything else is blank, I'll know that you didn't watch the videos. And I'm missing something here. What am I missing? I'm missing my end case. Yep. Alrighty then. Okay, good luck.